Okay, so taking a look at page 49, any questions on 1 through 6 you'd like me to go through? Anything on 1 through 6 on page 49?
Oh,
Number 6, you got it. All right, number 6. It looks like I have these points, right? Something like this, where this one is -2, -2. This is -1, -1. That's 0, 0. That's 1, 1. And 2, 2. Right? And they wanted us to say, find the domain and range represented by the graph. Okay. So the domain, I'm just going to underline in red, and we do the domain when we list it. We do it from left to right. So I have -2, -1, 0, 1, and 2. Now, if any of the numbers are listed twice, if you list them twice, you're totally fine. You don't have to. And then the range, we go from bottom to top. So it looks like they're the exact same thing. And that's, oops, +1 and 2. That's all you have to do. Is that the one that you wanted to know? See? Cool. That's all you have to do. Any other questions on page 49? So 1 through 6. We good? All right. What about, I'd say, why don't we run through 7, 8, and 9? Is that cool? All right. So problem number 7 says you have this function. Oops. That's a 7x. Excuse me. Okay. The function y equals 7x plus 35 represents the monthly cost in y dollars. So y is your dollars. And of a group of x members joining a fitness club. Identify the independent, okay, well, and the dependent. All right, so your x value is your independent values. And your y values are your dependent. Okay, it's always going to be that way. So the nice thing is, or the goofy thing is, everything in math seems to be alphabetical except for sorry. And then it says your group has enough money for up to 6 members to join the fitness club. Find the domain and range of the function. So your club is going to do anywhere from 0 to 6 people and anywhere in between. Okay, so you have 0, 1, 2, 3, 4, 5, 6. So that's our domain, square bracket, because we can have no one go, we can have 6 people go, and we have anything in between. As far as my range goes, so if I'm going to find my range, I'm going to plug 0 in for x. So 7 times 0 is 0. 0 added to 35 is 35. So if my company doesn't send anybody to the gym, this fitness club still charges them 35 bucks. And then I can have up to 6 people, so then I'm going to plug 6 in for x as well. So I get 42 plus 35. So that appears to be 77. So that's how I get my domain and range. So my domain is kind of given to us, in our range you have to plug in to get. So it looks like your company is going to spend anywhere from $35 to $77 for your 6 whole people to go to this club. I hope it's a small company. You got a company of 3,000. I can send 6. You need to work out. The rest you're gonna get fat. Okay. All right. Problem number 8. Let's see what 8 says. Number 8 says the Little Stage concert venue holds up to 200 guests. Okay, 200 guests. I'm just trying to make some notes. I don't know if this is going to work for the problem. For each event, the amount of money that can be made is a function of the amount of tickets, T, that can be sold. If tickets are $7 each, so 7 times T is how you're going to figure that out. All right. So you can't sell more than 200 tickets, right? So I'd say y equals 7t, And I guess you could say, tickets has to be less than or equal to 200 because if you can't oversell it. So I would say this is our function right here. And then determine the maximum amount of revenue. Oh, okay. So if I take the 200 and plug it in here, being I'm charging $200 per, I have 200 guests that can do it. It looks like I can have a whopping $1,400 that I make.
Ooh,
Yeah.
That kind of money.
Yeah, we're out of control.
I could.
And so our domains. Can I have 0 people show up to a concert?
Yes.
Yep. And I can have up to how many?
200.
So my range, I'm going to take those two values, plug it in. So if no one shows up to a concert, how much money do I make?
0.
Yeah, I make no money, right?
No money.
And if I have 200 people show up,
You make
14. Yeah. So that's all it is. And I guess we should make these square brackets as well. I guess you can make the funny ones. So you can have anywhere from 0 to 200 people at your concert. You can make anywhere from 0 to $1,400. And that's it. That's all we can do here. Does that seem okay?
What would you do with that kind
$1,400, man, I tell you, that's pretty weak event. I mean, I guess that'd be like a school play or something. I don't know. I think our plays out here, I think we'd have close to 900 people that show up to any given night, which is good for them. I think that's great. And then, oh shoot, we're back to the Uber. Did y'all think about my business model for the Stuber? Me saddling up a horse, putting on a saddle, and I'll walk people through the streets of Greenwood Village. All right, it says the Uber you ordered was going to charge you $2.50 and then charge you $1.10 per mile. So some people might want to clean it up and show it this way. Which way is correct? Your choice. So what does that 250 mean as far as the context of the problem? Yeah, you order the car and then you don't show up, they charge you $2.50 for it, right? Or you order the car, you go get in the car, you're already $2.50 into owing this company. And I know there was a student yesterday who was arguing with me in my other class. No, that's not going to happen. That's not going to. I'm like, okay, we're trying to just represent a situation that could be real. Well, yeah, but this is. I'm like, dude. Okay. So, write the equation that represents the function. Either one of those is fine. How much would it cost to travel 5 miles? Well, I'm going to put 5 in here. And then if I do my multiplication, I get 5.50 plus 2.50. So if I add those together, that's $8. Now I don't know if that's a good price or not to go 5 miles. I have no idea. Is it worth paying that much to go 5 miles? Well, I guess if it gets you there. I don't know. And then how far can you go if you only have $19? So what am I going to do if I'm sitting there, I look at my wallet or in my pocket or whatever, and I have $19? How do I figure out how many miles I can go? Help me out. Yeah. Yeah. I'm going to make this equal to either one of these equations. Both those equations are the same. So I'm going to go 19 equals 110m plus 250. I would subtract 250 from both sides. Does anyone have a calculator that can help me out on this? So I'm going to get real lost real quick. So that's, is that 1650? Thank you. And then I'm going to have that. How do I get m by itself now? Divide, so I'm going to divide both sides by 1.10. How much? Comes out to 15? So it looks like you, with your $19, can travel a whole 15 miles. So what's 15 miles? I don't know. I'd say from here to What do you guys think?
Maybe
Here to Castle Rock?
I
No, Colorado Springs might be a little further. But let's see. Let's see. I live 7 miles from here. So it would be on the other side of me. So if you were to go down to maybe Chatfield Reservoir, not Cherry Creek, but Chatfield over on C470 and where is that? C470 in Santa Fe. That'd probably be about 15 miles. I think. I don't know. I'm just trying to guesstimate. I have no idea. Yeah. Cool. Is there any questions about these? Everyone feel comfy? Be happy? Anyone sad? Is anyone crying themselves to sleep because of this stuff? You are? Good. Me too. I heard it's good to cry yourself to sleep. Releases.
Not surprised.
Supposedly releases all these endorphins. There used to be a commercial that used to be on TV that used to say, you know, why don't you just have a good cry? It's really good. And it would show like this woman who's like hysterically weeping as the commercial. And it's like, if you're hysterically weeping like that, there might be something more going on in life. Okay. Being the pages are goofed up, I would like just page 51 only. What was 9 what? You're kidding. 90. What is the minimum amount of
What are you
money?
doing? Why are you doing this?
He's going
Oh my
over.
gosh. Okay.
I guess the minimum amount of money you'll spend would be $2.50. Like if you just ordered the car and then you said, nah. Work? All right, so just page 51. So make sure your name's on it. If you're turning anything else in, that's fine. Make sure your name is on that as well.
Wait, what do you mean just 51?
Okay, so if you look at the page, 51's on this side, 52's on this side. They're no longer back to back because things are goofed up and you just can't have nice things anymore.
Okay.
Make sense?
No.
So page 50 was the second part of last night's, or 2 nights ago, homework. Does that make sense? It used to be just front and back, but the ordering got goofed up in this chapter. So now it's like, here's page 1 of my homework, here's page 2. They should have been back to back, but they got goofed up in the. So I'm only collecting one because the back side of page 50 is part of tonight's homework. Does that make sense?
Yeah, so which one are you collecting?
I am collecting the page 51 only. Oh wait,
That's tonight's. So page 49.
page 4. Oh wait, page 49. Jeez, you guys, good thing you're here because I'd be completely wrong. Page 49 is all I'd like to collect.
And then I have
Oh man. All right.
What? What are you doing? Go with us.
Yeah, you make that your permanent seat. I didn't mean to keep you in back. Come on up, buddy.
Hey, Aiden. Can I tell you something?
What do you got?
Draco got that Rico.
Me either. I'll give you those for exchange for those.
So it's just such an awesome phrase, you guys. I'm like, you know, just like say it. That's not gonna happen. No, it's not gonna happen.
All right. Let's take a look at these notes. And we're just going to write it on this page. This is just going to be our notes for today. And I think we're able to do it. But notice we have this on the front page. It just says, it's like a squiggly line. Agree? And I'm going to try and draw it the best I can. 1, 2, 3. And then I have that's like at 90. And that's it. Yeah, we're just going to do this as notes. And then 1, 2, 3, 4, 5. So that's 5. Okay, see if I can make this work. So this comes down here, bounces up, goes through this, keeps going, about 2.5. We're going to be maxed out, and then it's going to come back down like that. Okay. So I know that it's not the perfect thing, but let's just pretend it is. So let's say that up here, this is like 150. This looks to be about 2.5. So this point right here would be 2.5 comma 150. Does that seem okay? And this point right here would be 5 comma 0. This point right here would be 0.90. And then this point here would be -3, 0. Does everyone feel comfortable with how I generated those points?
Yes.
Anyone stuck on that? Okay, so what are the intervals where this would be increasing? So think about increasing. If I were to go from left to right, so starting over here and going that way, where does it appear I am increasing? Try and use the x values to describe to me where you think this would be increasing. What do you think?
2.5,
So just use the x components. So I'm going to underline the x components. Use this, 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 and this. Use any of those to tell me where you think this graph is increasing. Joy. So is it increasing here? Is this going uphill as I go? Tell me when to stop coloring this in. Okay, so it's increasing from -3 to 2.5. Okay, so this is what's happening in the x direction. And then by us saying that, we can say, hey, this is increasing from -3 to 2.5. Does that make sense to say that? All right, let's bring up red. Okay. So here and here, as I go left to right, it appears that it's going down. So what number is way far this way that we refer to in math? -infinity. And what number is way far this way? Infinity. Okay, so this is decreasing from -infinity to -3. And then it's also decreasing from 2.5 to infinity. Does that make sense? And again, I'm using the x directions to represent what our graph is doing. Okay? All right. Then it says, hey, we want the function at 2. We want the function at 2, f at 2. So that's going to say, hey, where does this appear to be? It appears to be pretty close to 150 as well. So what is the function at 2? That's what we're trying to find, is 150. See how, does that make sense how I just did that? I went on the number line, found number 2, and then went straight up or straight down to get there. All right, what about function at 0? So this is 0 right here. Where does this appear to be at? Where does that appear to be at? 90. Function at 0 is 90. And excuse me, the function at -3, what does it appear to be at? -3. 0. Perfect. Cool. All right, the domain of this, let's pull up a color we haven't used in a bit. That's kind of a unique green. The domain. So how far left and how far right does this graph go? Does it go from -infinity to +infinity in the x direction? Does it ever stop, or would you have to pick your pencil up if you were to draw this? now it's going to keep going. So it's going to go from negative to positive infinity. And then my range, what about my range? Where is that arrow right here pointing? It's pointing way up. So way up is what? And then way down over there is? So our range is going to go from infinity to negative infinity. So think about that. As I'm reading it left to right, the further left I get on this graph, the further way that way I get on this graph, the closer and closer and closer to positive infinity I am in the y direction, because that arrow right there is going to keep pointing upward. And then the arrow on the far side is going to continue to point downward. So as I go as far as I can that way, I will get to, or approach getting to positive infinity. That's my domain and range of this one. Okay? And then the intervals for where this function is positive. All right, let's see if we can figure this out. I'm going to bust out using a crayon. Okay, positive. So positive means I am above the x-axis. Okay, so I want to label where this graph is going to be positive. I want to label where it's going to be positive. Okay, so using the x direction is, so that whole green thing, everything above the x-axis is positive. So I'm going to go forever that way. So from negative infinity all the way up until I get to right here. What is this x value right here? 5. And it's going to be an open dot because right there at 5 it's 0. So I'm going to make this a parenthesis. Yay? Making that sense? Okay. Flip your page over and let's have you walk me through it. So increasing means that if as I'm going from the left to the right, my graph is increasing. So I have this kind of like that. I don't know. It's a lot more smooth than that, but just go with it. So where am I increasing on this graph? I'm going to show you from here to here, here to here. That's doing one thing. And then from here to here is doing another. So is the blue increasing or is the yellow increasing? And again, the verbiage I'd use is as I'm coming from the left and I'm heading towards the right, where am I going uphill? Is it blue or yellow? Does everyone feel comfortable saying blue? Anyone stuck on the blue? So this is in this direction coming from negative infinity, and then I'm getting to this point right here, and that point right there appears to be 1, 4. What do you think? And I'm just trying to make it the closest values. And then this point here appears to be, like, I don't know. Gosh, they didn't make it exact. It would have been nice. What do you think about 1.8, comma, negative 8.1? Would that be okay if I said that? And then this graph is continuing to grow this way to infinity. All right, so where is this graph increasing? Coming from, going to, you already told me it was the blue, right? Negative infinity to what? Use the x. To 1. And I'd make a rounded bracket. And then where is it increasing again? There you go. And again, I'm using my x values to give you this. Okay? Now you told me there's also a decreasing component on my graph. You told me that was the yellow part. Agree? So where's my graph decreasing? Use the x of the point to tell me where it's decreasing. Oh, that should be a negative 1, I'm sorry. And I guess that should have been a negative 1. All right, so negative 1 to what? To, what's this x component? 1.8. That's where it's decreasing. If we wanted to know what the function at 3 was equal to, so I'm going to count over to 3. 1, 2, 3. It appears to be right here. So the function at 3 is at? What do you think? If this is 3 right here, what's the function at 3? Not here. Yeah, it's just at 0, so it gets right there. And then the function at 0, is right here, so the y component's got to be 0. And then the function at negative 2, it appears to be right here. 0. Cool. Good job. The domain, does it go forever to the left and forever to the right? Yep. Does it go from the bottom to forever on the top? Yep. And this one is, being that's going way down to negative infinity first. As I come up, I'm going there. And then where is this function positive? Okay, so here, that's positive because it's above the x-axis, and this is positive. Okay, so where is this thing positive? Well, it looks like from negative infinity to negative 1, and then from 1.8, or excuse me, that would be 2, 3, because that's a 3 right there. So from 3 to infinity. That's all I have for you. Okay, we good? What'd I do? All right, so let's have you all work on page 51. Thanks, buddy. Oh, yeah. Yep. Page 51 and 52 are your homework for tomorrow, okay? Sound good? What time we at here? Oh, we got a couple minutes to call your own.